All right, let's start with our benchmarks. So here comes our dog Oscar. What's up, man? We're gonna leave this in here. I'm glad you interrupted, so I kind of was off to a rough start anyway. So, what's up, bud? Y'all want to meet Oscar? Hang on. Come here. Say hello, Ackermans. Say what's up. He's not much on being held, so he's not a loving fella. He likes to eat with you. He'll eat whatever you give him, but he does not like to be held. All right, man, we got to get to it. All right. Okay, so after that brief visit from Oscar, we're going to get to what we come here to do. And that was to actually do a little bit of benchmarking on our refurbished hard drives. Yeah, refurbished. If you remember correctly, as in the introduction video, I introduced the Western Digital HGST enterprise grade hard drives as refurbished. Again, this could be a mistake on my part. I'm not sure, so we'll find out. Only time will tell. We've got the Synology still sitting there. Well, not actually sitting there. It's out in my hopefully soon to be home lab building where I can actually do stuff like this instead of in my son's room. So I will probably never get rid of that for a good while, because if I have a catastrophic failure more than 2 drives, I will lose all of my data because of the way I have these VDEVs set up. So we will leave that there. I'm not too worried about it right now. So whatever, if I do add anything to the storage between the time that may happen, and I still got the Synology on standby, ready to plug back up and keep rolling on. So nonetheless, during all of this, I have never really done a lot of disk benchmarking before, and especially with FIO. And that seems to be the de facto tool that everybody uses in Linux to actually get a good benchmark on a non really graphical user interface, like such as TrueNAS. I mean, they don't have benchmarking your hard drives built in, which would be kind of cool if they did, if it was added into where you could run it. And they may have an app. I haven't really researched it, but everything that I come across, FIO was the de facto to use. And I've never used it, so I had to do a lot of research on understanding how it worked. And I come across this article. I will link the web address if you want to look at it, so you can hopefully get some understanding, as I did, about how FIO works. It's wrote by Jens Akbo. I'm sorry if I said your name wrong, but this gentleman, I did some research on him. I think he works for Facebook now. I think he did one time Noctinex, not 10x, maybe that's how you say it. But anyway, I think maybe he had worked for them at one time, but he's working for Facebook, so he has a whole Wikipedia page. So he must be somebody pretty important. He's a software engineer. But nonetheless, he wrote up a really good article that explains how FIO works. He talks about the arguments and what each of them mean. Then he gets down all the way down to the results, what you actually see spit out on the screen, and breaks down each what one of those mean. So very good article, Jen, or Jens, that you wrote. It helped explain it, but what I kind of got trapped, I guess, when you say, down a rabbit hole. And I knew what blocks were and sectors, and I understand pretty decent how a hard drive works and how it stores data. I even went back through this weekend and watched some more videos to make sure I was correct before I talked about it, because the previous recordings I felt like I was talking out my rear end, and told my wife that last night and said I need to re-record this video, because I really was talking out my rear end. So nonetheless, let's talk about blocks real quick. So in my test, you notice you set the block size. He gives some examples. Well, let's just pull my examples up of what I come up with. So I used his guide to write some. I did have to do just a little bit of digging. I do want to point this out. I am writing to a Samba share on this one, because I wanted to be able to manage those files that it writes and be able to delete them out. So if you're going to do it that way, once you create your new data set and you share it as a Samba share, you have to change that first part from -- file to -- directory, because you will be writing to a directory, not a file. This may not be the proper way to do it, but to get true results, but this is the way I did it. And you're going to see what I'm talking about, because I can actually go and delete this nearly 16 gigabytes worth of data we're going to write to it. So I kind of got down a rabbit hole on block size. Most of the time, anytime I've ever done anything, I've just let it always be default to whatever the system formats the drive as, whether it's NTFS or inside of Linux. I've never actually changed or got into block sizes before. So I believe most drives, and these may fall into that category, fall in under the 512K block size. And I believe I read TrueNAS goes between 128K and 512, depending on the file size that is being wrote. I believe I understood that correctly. If I'm not, just let me know. And I got to go digging down a rabbit hole, and then I found advanced formatting that most new drives are going to advanced format, which supports a 496K. And I would assume that's 496 would equal 4 megabyte cache or block size. And the claim is the larger the block, the more efficient it is, according to this Wikipedia. Of course, Wikipedia is not always correct. But you look at the difference between the two block sizes, and according to them, it's only 88.7% proficient with 512, but with 496 byte sectors, you get 97.3%. And it would kind of be interesting to see efficiency storage, because I know a lot of you out there that host home labs are just like me, and you have all your media on either Plex or Jellyfin or some other form of media server. And is it more efficient? I mean, would you want to seek out drives that store in a 496 byte sector, or byte 496 blocks or sectors, or whatever you want to call it? Would it be worth tweaking it? Because I think you can in TrueNAS, if I was looking correctly, before you actually start putting data on it. If you go to data sets, let's go here. I want to go fast. Edit. We'll go to the advanced options. We scroll down here, metadata, special small block sizes. You can actually change the block size. So 1K, 2K, 4K, 8K, 16K, 32, 64, and then I would assume this flips over to the other side of the spectrum until you get to the 1 megabyte block size. So you can set the block size all the way up to 1 megabyte, but I think the default in the inherit 0 is either 512 or 128 that it uses. So would it be beneficial to up the block size if that's all you're hosting on that storage pool? I don't know. I may do a test on it. I don't think you can change it once the data has been wrote, but I do have a test unit, and I have a 4 terabyte drive laying around, so I may pop it into my USB drive and plug it up and see if it makes a difference in the efficiency. That might be a pretty interesting video. But like I said, these are opinions. There's stuff. I had to do a lot of research, and the results that I've gotten a couple times, I've been pretty impressed, and we're going to run those results now live. I want to make sure, again, we don't have any data that you see that's been wrote to this storage share. We're going to go to our dashboard so we can see it. Our ZFS cache is sitting pretty empty right now. It's because I just rebooted the machine to dump that out of memory. So you will actually see how ZFS actually works. And if you're a fan of fast reads, which you would want on your media server, then this probably is the best way to host the media server. So let's get to it. Let's clear out our screen. These are some of the results we were getting earlier. Then let's pull up our stuff. I want to change this back to 1 megabyte sequential writes. Well, no, let's leave it at 512, because that's truly what, if I read correctly, what the block size set to default in TrueNAS. And these would be considered large files. So copy. I know we copied that. Copy maybe we didn't. Copy. Just do it that way. Alright, so if I open up my share, while that is running, I should see data in it. Yep, see 40 files at 400 megabytes apiece. 15 seconds left. Getting about 840 input-output operations per second. So on our right, we got 553 megabytes with our IO of 15.5 gigabytes, which equates to about 6 gigabits, and which equates to about 16.6 gigabits throughput. I think that's fairly decent, to be honest with you. I can't complain. I mean, those are refurbished hard drives. I think they were manufactured in 2018. It's not too shabby considering the overhead of Samba and the overhead of this system writing to those older discs. So what was our ops? So we've got an average of 1,014 with a max of 11,544. So guys, let me know what you think. Do you think that's fairly decent? Or if it's not, say your drive sucked, Joe. Should have went with new ones. So let's do a random read of that data. We're going to leave that at 5. Let me change this to 512 so it all matches. Okay. Right, our screen, so 553, and you should see a huge performance increase because this stuff is now stored in the ZFS cache. All that data that was wrote, and you can see it went from 13 or 3.9 to 19.9. So you definitely know it's in memory. So that is where it's going to read from. And in the background, like I said, if I understood it correctly, it commits it's like a transactional type deal. Every 5 seconds, it commits it to disk. All right. So there we go. We got 17.3 gigabytes per second. We got 4,000, let's see, 518 gigabytes on the IOs. Our IOPS were, so our max was 55,433 and our average was 32,913.98. So you can definitely tell that is not reading from a disk. That is reading from the ZFS cache. So I believe as far as if you're running a Plex server and you have ample memory in it for how I have this set up, it's going to eventually store the most used movies into memory or that layer 2 ARC cache that I have on it. So either one of the two, it's going to have super fast read speeds. Let's clear out the screen again. Oops. And let's do some random writes. And let's see how the drives perform with random writes the same block size. All right, here we go. Now we do see a little bit of performance decrease, and this should be because this is random. So you shouldn't see as fast speeds as you would with a streamline of data. This is just randomly writing data to the disk. So there is a performance decrease, 493, and the IOs was 14.8. And the IOPS was 896 with 11,415 as the max. So, what do you think, guys? Did I get gypped or am I on the winning end? Because I feel like I'm on the winning end, to be honest. All right, let's do some random reads. Let's clear out our screen. random reads. And you can see on these random reads, we're really, really pushing this machine to its max on the CPU usage every time. So we got in the 40 jobs, the way I understood it, there was a video I watched, it's like 40 clients requesting this 400 megabytes of data all at one time. So that's why we're seeing such high CPU usage. And I guess it's a good stress test on the CPU. And as you can see, it did not back and did not bulk at this at all with this DDR5 RAM. 17 gigabytes per second. The IOs were 510 gigabytes. I mean, good God. Did I make a heck of a system? I mean, I think I did, and I could be wrong. I don't know. Let me know what you think. So we'll kind of spin back around. Like I said, last night it led me down to a deep rabbit hole of how block sizes work, what is actually the best block size for media storage, and the new advanced formatting on hard drives. So, like I said, there's a Wikipedia that shows that, you know, at 496 bytes, you get 97.3%, and that is the prettiest, is what, a little over 11% maybe performance, or more space, and that kind of equates to a lot if you are over terabytes worth of hard drives, over terabytes worth of data. I mean, that could mean a substantial gain in disk space or disk usage. Well, not disk usage, but maybe better use of the storage. But nonetheless, like I said, it definitely led me down a rabbit hole. I spent a couple of hours researching it, and I told my wife, I said, I just want to make sure I'm getting this right, and I still probably butchered it really bad, but that's like you got warned, this is the ramblings of a so-called home lab enthusiast. But anyways, that concludes our test on these drives. Let me know what you think. Did I get ripped off by buying a refurbished hard drive and should have went with new? Or did I get a pretty good deal? All right, well, just let me know. We'll see you in the next.